Hello everybody and welcome to another Weather Wednesday. My name is Elias Mullen and I'm here at the Space Foundation Discovery Center using Science on a Sphere to tell you a little bit about space weather. Yes, we've been talking a lot about weather around our Earth recently, but a number of people have been asking, what about space weather? What is it and what can we learn about it? So today I'd like to talk about some basics behind space weather. Behind me here we have our sun. Now, I'm not too warm right now because this is just an image of the sun. It's not the actual sun, but one of the interesting things is that if this was the actual size of the sun, this is how big our planets would be compared to our sun. You can see that we are that third one on the left there. We're pretty small compared to the sun. And in fact, if you look at some areas on the sun, there's these dark sunspots. And we'll get to that in just a little bit. Do you guys know what the sun is made of? Here's an interesting image of the sun. You notice it's a little bit of a different color than the last one. That's because we can see the sun in different wavelengths. And that helps us to see what the sun is made of. This one is actually seeing iron. You see, the sun is made of hydrogen and helium, and as it fuses, or as these molecules and atoms slam together, they create new elements in our periodic table. Iron is the heaviest element that a star can make by itself. And this is looking at the iron production of our going on around our sun. Here's another interesting color, if you will, of our sun. This is looking at the sun in ultraviolet. Now, we can't see ultraviolet with our eyes, so we have to give ultraviolet data a specific color. Our eyes are very good at differentiating, seeing the difference between green colors. And so scientists use the color green a lot when they want to really look at fine details. Now, this is an image of the sun taken back in 2003. During 2003, there was the sun was quite active. There was a lot of solar flares and coronal mass ejections. And what I want to show you one of those events here on this side. Now, watch closely. As I bring this forward, you see that bright flash right there? That is a big eruption from the surface of the sun, where charged particles are blasted off into space. Now, if you remember back in science class, or if you are new to science, everything around us is made of atoms. And atoms have a center nucleus, and that nucleus is typically made of protons and neutrons, and they're surrounded by electrons. When you are as big as the sun and you have as much gravity as the sun does, there's a lot of interesting things that happen on the sun. One is that these atoms fuse together. That means they're slammed together, creating new elements. During that process, those protons and those electrons often are blasted away or stripped away from those atoms. Those electrons, having been stripped away or very excited, give off different colors of light. Ultraviolet is one of those colors of light. Again, we can't see the ultraviolet with our eyes, but we can detect that with satellites. So here we see a big blast of those electrons and that high energy particles blasting off the sun, and that is what causes all of these, what I like to call bugs, hitting the windshield. So these bugs right here are overwhelming the detector on the satellite and causing it basically to kind of go staticky. Now, what happens if those charged particles hit the Earth? Here is an animation showing one of those big blasts from the sun streaming out into space. And if the Earth was in the way, those charged particles would interact with our magnetic field. And you can see here, our magnetic field surrounds the Earth. comes out of the South Pole, goes to the North Pole. And since charged particles interact with a magnetic field very easily, those charged particles are basically rerouted or streamed towards the poles of the planet. And as I fast forward, or as I play this, you can see that these magnetic field lines come together behind the Earth. And as they touch and recombine, it shoots those charged particles back towards the poles of our planet. And that's what causes the aurora borealis, the northern lights. Or in the South Pole, you would call it the aurora australis, or the southern lights. So on both parts of the Earth, both hemispheres, both poles of the Earth, you can see these brilliant colors high in the atmosphere because of those charged particles that are interacting with that atmosphere. So back to our solar flares and our eruptions here. So there's that big event and all these charged particles here. Now since these are charged particles, they can interact very easily with things like electronics, the electronics on satellites. They can even, the high charge particles, or the high energy particles, can even harm the human body. So it's really important that scientists study the sun and watch the sun, because these events is what is called it's called space weather or solar weather. So as the sun goes through this fusion event and gives off these charged particles, it creates kind of a solar wind because it's constantly doing that. And these charged particles have mass, so it streams away from the sun and basically blows through the whole solar system. And we can see the effects of the sun, which is called the heliosphere. We can see the effects of the sun all the way past Pluto and past the Kuiper Belt. It streams out way, way far into space. So that solar wind creates space weather all the way throughout our whole solar system. So scientists that study these the sun and watch the sun, they are actually stationed in Boulder, Colorado, at the Space Weather Prediction Center. And so they're constantly watching for solar events. Some of the things they're looking for are sunspots. That was that dark area that I showed you in the yellow. Right before this event happens, you can see this bright area right here. And there's another bright area above it, so on and so forth. Those are called sunspots. The number of sunspots that are found on the sun, it will dictate how active the sun is. So what's the space weather like right now? What's the space weather forecast? Well, right now there are 0 sunspots on our sun. That is because our sun is in what's called a minimum phase. It's at a solar minimum. This is an 11-year cycle that the sun goes through, where every 11 years you'll get a spike. It's called a solar maximum. And in between those 11 years is a solar minimum. Right now we're in our solar minimum. We should expect the sun to be in its solar maximum about 2023 or 2024. That's about when our next solar maximum will be. And that's when scientists will be looking for those active sun spots. Now, I want to encourage you guys, if you have any questions about space weather or about these topics that I'm talking about, please add those to the comments on Facebook or send us an Instagram or Twitter. We love checking our social media. And in fact, I do see that we have a question. One of those questions is, do other planets have northern lights? And that's a great question because what you need to have northern lights or an aurora is you need the charged particles coming from the sun, which is the sun is constantly doing, and you need a magnetic field. So that second ingredient is very important to have aurora around a planet. Do you know which planet has the strongest magnetic field? It's not the Earth. If you guess the Earth, the answer is actually Jupiter. Jupiter has the strongest magnetic field in our solar system, and it has a lot of aurora that happen on the northern and southern poles. So there you have it, a lot of information about space weather. If you want to find out more information, feel free to check us out on discoverspace.org. Feel free to email us, send us a message. Also, you can check some internet sites. One site I like to visit is called spaceweather.com. Space weather gives you all the latest about what's happening around with the sun. Also, if you're interested in aurora, the northern lights or the southern lights, University of Alaska Fairbanks has a great website as well to tell you what the activity is and kind of help to predict what the forecast is for aurora. So you can check out those websites on your own. Well, that's all the time that I have for now. If you have suggestions for our future Weather Wednesdays, please add those to the comments as well. Thank you for joining me, and make sure to follow us on Facebook, on Instagram, and Twitter. We look forward to seeing you next time. Thanks for joining me on today's Weather Wednesday.